This is Mrs. Bohatch, and this Explain It is about counting significant figures. Here are 5 statements that help you count significant figures. In the first statement, you can see that any number that is not 0 is automatically significant. So in this example here, we have 5 digits that are not 0, so they are all significant. So there are 5 significant figures in this number. In our second example, any 0 that is sandwiched between 2 numbers is automatically a significant digit. So in this example here, we have 3 significant figures. In our next example, any zeros that are to the left and not sandwiched at all are not significant. So in our example here, these zeros do not count. There are only 2 significant digits, the 5 and the 4. In this example, zeros to the right and at the end of the number are significant. So in this example, there are 4 sig figs. The 8 and the 5 count, and these 2 zeros count also, for a total of 4. In this final example, zeros at the end of the number with no decimal point are considered not significant. So in this example, we count the 2 and 5, but we do not count the 0, 0. Now, somebody could change this to make it significant if they put a decimal point at the end of this number, and in that case, then, it would change it to 4 sig figs. An easy way to remember how to count significant figures is to use something called the Atlantic and Pacific rule. Imagine that you have the United States here. And the Atlantic Ocean is on this side, the Pacific Ocean is on that side. Now we're going to use the first letter of the names of the oceans to remember our device here. So P, Pacific, we remember if there's a decimal present. We'll start on the Pacific side. A represents the decimal absent, A Atlantic. We'll start on the right side and count significant figures from there. So here are some examples. All of these possess a decimal point. Therefore, we are going to begin on the Pacific side, the left. And we are going to swim until we find a number that is not 0, and then we are going to count all the rest. So in this example, we'll count this one, this one, this one, and this one. So you will have 4 significant figures. In this example, there's a decimal point, and so we start on the Pacific side. We swim until we find a number that's not 0, and then we count all the rest. So in this example, we have 1, 2, 3, 4. 4 significant figures. Now on to this example. We have a decimal present. We start on the Pacific side, and we swim till we find a number not 0. We count all the rest. It doesn't matter what they are. You count all the rest. This one, this one, this one. There are 3 significant figures here. In the last example, there is a decimal present. We start on the Pacific. We swim till we find a number not 0. That'd be right here. And we count all the rest. It doesn't matter what they are. You count all the rest. 1, 2, 3, 4, 5, 6, 7. So this number has 7 significant figures. Now we're going to look at some numbers where the decimal is absent. So if the decimal is absent, we start on the Atlantic side. We do the same technique. We swim until we find a number not 0, and we count all the rest. So in this example, there are 3 significant figures. In this next example, the decimal is absent. You start on the Atlantic side, the right, and you swim till you find a number not 0, and count all the rest. So in this example, there is just 1. In our last example, the decimal is absent, so we swim until we find a number not 0. We count all the rest. We don't care what they are. We count them all. 1, 2, 3, 4. So this example has 4 significant figures. Remember that significant figures have to do with measured numbers, the uncertainty in measured numbers. So we have to take a look at counting numbers. Counting numbers are, for example, 1 dozen eggs is 12 eggs. This 12 number is said to have an infinite number of significant figures, and so therefore we don't use it to determine the overall certainty in our calculation. So we wouldn't look at this number in a calculation when we were determining the significant figures. The same concept applies to conversion factors. This is not a measured number. It's an exact number. In other words, in 1 inch there are exactly 2.54 centimeters. There's no uncertainty in that. Therefore, we would not use this number in calculating or considering our overall certainty.